And we're back. So today we actually got a ton accomplished. There are four things which previously I had not had much experience with at all, but are vitally important for software engineering. The first one is unit testing, second one is integration testing, the third one is doing pull requests, and the fourth one is going to be the GitHub Actions, that CI/CD pipeline. So before today, I had not dealt with either of those four things, and I wasn't even expecting to really get to them today. I was thinking about more just creating the documentation, seeing if I could go and just do the documentation for implementation of unit testing. That was what I was planning on doing. But then Copilot had some other ideas. It was like, okay, well, I'll do this unit testing. I'll also throw in some integration testing. Would you like the CI CD? Would you like me to make a pull request? Would you like me to, what was it, to be able to set up GitHub Actions, right? So all along the way, I was like trying to contain it a little bit because it was going too fast. And I was hoping more of the documentation, and that way we would be able to go through it and understand it step by step by step. But it had other ideas. It wanted to go. So we did all four of those things. And now in the last video, I was trying to understand okay, so today I don't know, three videos, maybe? I think this is the fourth video. But so in the first video, yeah. In the first video, I was talking about, I was just getting, working with Copilot, getting that actually working, getting the documentation, getting all of this, just collaborating with Copilot. The second video was understanding, okay, well, it did a ton. What state am I in? Where am I, like in terms of which branch I'm on? What is this pull request? What is it even doing? What's the purpose of a pull request? How does a pull request work? How do I move forward with the current state? Because I had no idea. And then I was also saying GitHub Actions, which I have no idea what that meant either. And trying to do all of these tests and how does all of this fit together? So that was the last video, was me going and trying to investigate, okay, well, how is that working and what's going on there? Now, today in this video, what I am planning on doing is going through more of what was created. So let me make myself a little bit smaller. Here's where the pull request was. And in the last video, we were going through this, and eventually we were able to get it successfully merged. And now if we look here, once it loads, we'll see that we were able to get it merged. So the the branch is still here, and it suggested deleting it, but I hadn't done that yet. But yeah, we can see like 5 hours ago was when we did the merge. Okay. So now what I want to do is I want to open up Visual Studio and continue reading this, go through this document, and this is the suggested unit test that Copilot gave to me to try to tell me what it would suggest for a unit test. Then I also want to go in and actually look at some tests and figure out, okay, well, what is it doing and how is it interacting with my actual project? So today I feel like we moved really quickly, but now it's time to make sure that we absorb the learning from that quick movement and make sure that we understand what's going on so that way we're able to move boldly ahead. Now, I feel now, so video number one was we just moved really quickly and I had no idea what was going on. Video number two, I feel much more confident and comfortable understanding where I am and about GitHub Actions and uh, the pull request, what a pull request is, and how this will interact together. So the unit tests, how the unit tests are ran through the GitHub Actions, how a GitHub action is actually configured, how GitHub communicates with the, it's up here, the YAML file that we have in our project, how your unit tests running GitHub Actions are kind of a blocker from a separate branch to be merged into the main branch. And that process is called a pull request, and you have to review it and bring that code into your main. Okay, great. Now, that was the last video. We were able to be like, oh, wonderful. We understand how all of that works. And we made a ton of progress and learned a lot. Now it's time to continue learning, and I want to focus more on the actual unit tests. How do you do unit tests? What are they actually testing for? And that direction, okay? So let me get a drink of water and let's start. So, suggested unit tests. Okay, we already read this and so then obviously we're going to have Copilot here to be able to give us a good avenue for asking follow-up questions. So we have our mocks. Okay, so tests by component. Each section lists concrete tests for the component. Okay? Each section lists concrete tests for the component. Campaign model. Okay, so let's open campaign model test. Okay, campaign model. So it's going to be in models. Bid engine model campaign should be this one, right? So campaign can serve returns true when active with budgets. Okay, let's see if campaign can serve returns true when active with budgets. Okay, so we have this here, and we have fact, 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 fact. All right. So we have, I think that's 5 facts. The goal: validate the can serve business invariant for daily and lifetime budget status. Okay, so can serve is a field within one of my classes in my main project. And the idea behind it is I have an advertisement and I want to know if I can serve this advertisement. And one of the blockers, so there's 2 main blockers for if I'm not allowed to show the ad. The first one is going to be if we've already gone over the daily budget for that campaign. So maybe this company says, I only want to spend $100 per day on advertising. Okay? If we've already spent $99, and this ad is going to cost $1.20. Oh my god. I wish ads costed $1.20 per time viewing. Oh my goodness. Okay. No, a more realistic number based off of what I've seen here on YouTube, at least for my channel, is like it's going to be about $6 for every 1,000 views, so somewhere around there. And so anyways, but hypothetically, like if we were about to go over budget, then we have to say, hey, we can't serve this ad. We're not allowed to because it's gone over budget. The other blocker is if we are over the lifetime budget. So maybe this campaign says, in total, I only want to spend $30,000 on ads. Okay, if we've already gone over that amount, or if we're about to go over, and this ad is going to put us over the tipping point, we can't serve it anymore. So that's kind of what this can serve does. So now I say can serve returns true. So returns true when active and within budget. So I am testing that this can serve variable, which is part of the campaign class, will return true when these two things are met. Okay, let's come in here and let's see how we're looking at this function here. just I just ate, so now my throat is like. Okay. So we're getting this campaign here. So we're creating a new campaign. We're saying that it's active. Our daily budget is 100 M. Daily spend today is 50 M. Daily budget is 1,000. Lifetime spent is 200. And then I say C can serve should, okay, can serve, where is okay, that's the campaign object, my member variable, and then there's something on here that says should, so I'm where is this should coming from? Because if you're telling me that it's coming from this X unit here, this syntax makes it seem like it is a member, or it is a method of the can serve object, which I'm not convinced of. And then be true. So we set up the arrangement such that we will get a true when we're within budget. So that's what we did here. Can serve returns false when not active. Okay. So he paused it and then said should be false, and then we say we're going to make sure that it's false, and if that's true, then we return true here, and this unit test passed. Okay, campaign can serve false when spending is equal to. Okay, all of this makes sense so far, actually. This is a lot easier than I was thinking. When lifetime spent equals lifetime budget, we should return false. Yeah, that makes sense. Okay, I mean, that makes a lot of sense right there. So let me try. I'm going to come and look at the models and in my project, which is here. And then I'm going to say Bitengine models campaign here. Okay. So here's this. Okay, that kind of makes sense. So describes new active campaign. Should be true. All of this kind of makes sense. Yeah. Campaign cache. Let's go and look at campaign cache and see if that's a little bit more interesting. The one that we just did was like, okay, it makes sense. We just like verified that each of those items was correct. So campaign cache. This one is services, right? Campaign cache tests. Okay. So now we're going to come here and get campaign async. Will return the cached value when present. Okay. And this is something that I'm going to be a little bit confused about because we have to interact with Redis in this in this situation. Oh, and I forgot to ask my follow-up question. Okay. Say here, actually, I'm going to say like this, and then I'm going to come in here and ask my follow-up question about where is this method of dot should if it is part of the X unit. It seems as if it is a method within the can serve object. Okay, so we asked that question, now we can kind of close that. Let it do its thinking and find what the result is. Alright, so how is this working? The method should is not part of XUnit itself. It comes from fluent assertion. Okay, well, again, that's just kicking the can down. That's just saying the exact same thing. Fluent assertion extends objects. Oh, okay, with extension methods like .should. Okay, so here what happens is can serve is a boolean. Fluent assertion provides an extension method should for booleans. Okay, that makes sense. That returns assertion objects and methods like be true, be false, be equivalent to. Okay. So we have XUnit. Fluent assertion. There it is. Okay, cool. Yeah. Okay. Makes sense. Okay, campaign cache. Ensure correct cache hit miss logic. So we're just going to be looking at the hit miss logic. But in order to do so, we need a Redis connection. JSON serialization behavior. Okay, see how the JSON is serialized and the, was that time to live, key and validation. Okay. So, campaign cache get campaign asynchronous. Okay. Returns cached value. So it returns a value which was cached when there is value present. If Redis returns JSON for campaign ID, then DB should not be called. And the deserialized campaign returned. Okay. So why are we doing this unit test? Confirms cache shortcut path and avoids okay, never mind. Database queries. Mock iDatabase string query async. Okay. So we're mocking this to return JSON assert this is not queried, or mock DB called to ensure it is not evoked. Okay, so let's come in here. Public async task. Okay. So we're returning a promise, right? We're not actually returning anything, so it's a void promise. All right. Connection is mock iConnection multiplexer. This is what communicates to Redis. We get database. That is the SQL database. So we're creating mocks of these. Logger is, we're creating a mock Microsoft iLogger object, which was customized for campaign cache. Okay. I can't tell if, like, when I was watching the other one right now, that sentence didn't make much sense, did it? When I was looking at the other unit test, I can't tell if I am starting to understand C sharp a little bit more, and so things are starting to, click, and I feel a lot less lost than I was even a week ago when I was doing this project. But now I'm looking at all of this kind of stuff, and I don't feel extremely comfortable with it, obviously, but I'm understanding a little bit more because in the past, if you just go back like a week ago and see my videos from a week ago, when I saw these angled brackets, oh, that threw me. I was just, I don't know what's going on. I don't like this. I hated that. And then we had all of those anonymous functions, and you know, but now I'm starting to, okay, I get it. And I'm also feel like I understand more of object oriented programming methodology and just feel a little bit more comfortable with it. Again, I don't think I am comfortable with it at all. I have a lot more to learn and more. I'll continue to get better and better at it as I do more of the project. And so, but I just wanted to make that observation that I'm like, okay, well, I've been working on this project and I definitely feel like I'm getting more and more familiar and comfortable with a lot of the concepts which are present here. Okay, so we're creating some mock which is customized for, this is a generic object, generic object customized for an iDatabase interface, okay? Now, what are we doing? Campaign, we're creating a campaign, new campaign, and we are doing ID is global unique identifier, okay? It's um, Microsoft's way of doing the unique identifiers, and then name is X, it doesn't matter, but it's required, so it's there. Then we do JSON is JSON.serialize. Okay, so here is one of those really cool things which we have learned in a couple videos ago. This, so this project, I started this project I think 2 or 3 weeks ago, somewhere around there. But before I did this project, I did other projects. First one was JavaScript, which was Node.js, Express, and being able to do API endpoints, things like that. Then I moved to a Java program or project, and that Java project was interacting with its concepts. And one of the things which I was constantly stumbling over myself was sending data and receiving data and translating between JSON and JSON strings and JSON objects. And I couldn't understand why I was getting errors. And now in this project, we came into that problem again, but I was able to investigate it. And now, with the extra context that I had from the other projects, now I'm like, oh, that makes a lot of sense what's going on. So, serialize, what this does is this, the way that I remember it, SE, right, is the same as send, SEND. So this prepares this to be sent. And how do you send something? It's through a string. You don't send an object. So this is an object that is going to be stringified, okay? And this JSON serializer is just the library that we're using, okay? So the return value is going to be a string variable, and it even says it right there. String could be nullable. So this is an object. This is a C# object. If we even want to see that object, model, campaign. Here it is, campaign, right there. This is a C# object. and we are creating a new campaign. Okay? Then making it a string, and then we're going to be able to send it. All right, so now DB, so this mock object set up for an iDatabase has something called setup. I haven't necessarily seen that before, but okay, we're going to investigate it. Now, once again, this previously would have this previously would have gotten me all worked up. But let's see if we can figure this out, okay? D, and there's two things that sometimes it means. Sometimes we are doing a function and then we return something and pass that in as a parameter. Other times we are passing the function in itself as kind of a factory. And there seems to be two different things that we are doing based off of the convention, which is this method. So what is this method actually expecting? Does it even say? Okay, let's see if we can find out based off of this. Okay. Mock language flow iSetup. Instead of going to Copilot, I'm trying to look at here to see like, okay, well, can I find out what it's supposed to, what the input parameter is trying to do? I see expression right there. System LingQ, and LingQ is the translator between C# objects and like the SQL language. Okay. Funct iDatabase an asynchronous Redis value expression. Okay, so we are passing a function in. And then so it makes me think that this is an anonymous function that we are passing in. Okay. We're going to confirm that with ChatGPT in a second. But let's say we pass in a D, whatever that means. Okay, well, it says database, but okay, fine. We're going to come in here, and we are going to get that database. So string get asynchronous. So we're going to do an operation on this database here. And we are going to IT was allows the specification of matching conditions for an argument in a method invocation rather than specific argument value. It refers to the argument being matched. I think that this one was like there's is any. And I remember we saw this a couple videos ago. I forget how many videos ago, but I remember it can like match any object or something. So it can match any Redis key. Okay, so for any, like, not the Python for, but okay, I just recalled what it meant. Sip of water. What it meant was that it doesn't matter what Redis key I pass in there. It will accept any Redis key that I put in there. But I'm going to put in a specific one. It's like saying it.isAny and then name. It can be John, it can be Tim, it can be whatever name we want. Microsoft, I'm seeing. Dell. It can be any name we want. We can put that in there. It will accept any argument that is of type name. Okay. Like this one, it is any command flag. So we can accept any parameter, which is a Redis key and a command flag. And we're going to pass that into the get asynchronous. So now returns async. So we get that object, or no, we get that string here, and then we cast it as a Redis value. Okay. Where is Redis value defined? It might be here in Redis. Go to definition. Maybe that was the wrong thing to do. Okay. So Redis value here, we are inside the namespace of Stack Exchange Redis. Awesome. Actually, this is kind of cool. Okay, normally when I do like that find definition, it just says no. No definition found. Like, great, thank you. But now this, okay. We got it. So it implements this interface custom for a Redis value, equatable, okay, comparable, and it also has an interface of this. So why do we have custom ones and non-custom ones? Internal enum, storage type. Okay, where are we, by the way? Does it show where we are? No. So we're able to see the code, but that means that it's stored somewhere on my computer. Maybe it's here, right? Var folder bz something here, generics, metadata as source, something even more random, decompilation as, oh my goodness, Redis value. Okay. Like, that was a pretty long chain of events to get to this location. Internal static, read-only, Redis value. And that's what we were looking for, right? Redis value. Redis value. Hold on, is there a capitalization thing? Oh no, it's a Redis value array of Redis values. Empty array. Okay. Object or Sentinel. Read-only memory. Overlapped bits. Sentinel signed integer. Browsable false. Editor browsable editor. Okay. Public boolean is integer. If object or sentinel does not equal sentinel signed integer, return this, otherwise return true. I mean, this isn't really what we were trying to get into today, though. Okay, anyways, we're casting it and returning asynchronous. All right, let's try to get this. Come here. Paste that into here, and then I want to say I want to understand how this mock object is created and of my items. I am also noticing that I am only passing in an interface instead of the actual class to the generic type. Okay, then I'm going to be going and asking about this statement here, but I wanted to give it a little bit of context before we jump too far. So how does mock T work? This is part of mock library. It creates a mock object that implements T. T usually an interface or an abstract class. Abstract class. Abstract means not able to instantiate, because mock generates a dynamic proxy that can stand in for that type at runtime. Okay? This creates a mock object that implements all of the iConnection methods. You can configure its method with setup. That's what we saw. We're seeing setup. Okay. Why interfaces instead of classes? Interfaces are easier to mock because they only define contracts, method, properties, not behavior. Mock can generate a fake implementation at runtime. Okay. And that's probably why we were passing in that lambda expression to the setup of that mock object, I guess I can call it. I'm trying to say the words properly. Okay. If you tried to mock a concrete class, mock would need to override virtual methods, which is more limited and sometimes impossible if methods aren't virtual. So virtual means that you're allowed to override them. Okay. Var db equals new mock iDatabase. Yep. Customizing the mock. You customize behavior with setup. DB setup here. So this long thing that we still need to investigate. Setup tells the mock. Okay, great. What does it tell it? When someone calls string get asynchronous. Okay, so it's not the fact that we are actually calling this string get asynchronous and then passing in the function. We are setting up, okay, now things are making sense. We are setting up this method to say, hey, when someone calls this, okay, with any Redis value and any command, return this. Got it. Got it now. Okay. Return the JSON string. Now, actually, I don't even know if I need to ask a follow-up question on that because it makes sense now. Yeah, I mean, that's pretty cool. It makes sense. So I'm chaining this returns async on the setup method. And I'm saying, okay, well, when anyone calls this method here with any Redis key and any command flag, I just return a string, which string is this campaign string, but I cast it as a Redis value. Okay, so let's go to the next one. Wait, thankfully I didn't put this in Copilot, so it doesn't know about it. So let's keep reading, and I didn't want to keep reading because I wanted to do this kind of myself, but thankfully it doesn't know the context of that one, so we can freely read. All right, so logger, mock of logger. So is it mock of? Yeah, so what's this of doing? Creates a mock object of the indicated type. I mean, that's the same thing, right? Like, mock of is shorthand for give me a mock of this type with default behavior. Okay. You don't need to configure anything unless you want to verify logging calls. So mocks stand in for dependencies like Redis, databases, and loggers. You pass interfaces because mock can easily generate fake implementations. Okay. Right. Connection. So now we're going to connection and we're setting up get database. So whenever get database is called, it will accept any integer and then any object. Okay. And then what do we return? We return database here. Dot object. What is dot? I guess I don't understand this one. What is like just dot object? What is dot object? And how are we returning it? Did I define object in my database? But if I am passing in only the implementation of iDatabase, then the method wouldn't be there anyways. So I'm trying to find out where that object actually comes from. So what I'm thinking with this project is there's a lot of stuff going on. And as I just said, today we've moved really fast and got really far. I want to continue to look through these unit tests. I want to see if we can add some more. I want to go forward with that. I also want to go and kind of understand how just more of this a little bit. But what I'm thinking is once we get the unit tests, we'll be able to start building things out even more. So I'm thinking that we start going into like analytics service and ad service or ad server, and that way we get even more practice about building it, and maybe we can be a little bit more hands on. And yeah, then we can, yeah, okay. Okay, what object is? When you create a mock with new mock T, you get a mock wrapper around a fake instance of that type. Okay? The object property gives you the actual mocked instance that you can pass into your code. This is an iDatabase. Object is not something you defined in iDatabase, it's a property provided by mock itself. Why you return object? In your setup here, connection is a mock of connection multiplexer. You're telling mock when someone calls get database on this mock, return the fake iDatabase instance. So I'm returning the instance, but not the actual instance, the mocked instance. And that is from an interface somehow, though. So you're chaining mocks. Connection pretends to be a Redis connection. When asked for a database, it hands you back a fake database. Why interface works here? You don't need a real database class. Mock generates a fake implementation of iDatabase at runtime. That fake object is what object means. Okay. So that's fine. Sure. I also don't want to get too bogged down on everything. So I'm trying to also kind of move and say I generally understand it. I see what's going on. And then I can move on a little bit. Because we need to move fast as well. So we need to learn as much as we can and move quickly. All right, database context options builder. So this one is not a mock. This is a real thing. DB context options builder. Bitengine, data, app, DB context. So we wrote that. DB context is controllers. No, that's big controller. Where is app DB context? Here it is in data. Okay. So we have this here. And we are setting up on model creation. We're setting up the actual database and all of the tables. Okay. All of the tables and all of the columns for the SQL database. So this should evaluate to the class that I just showed. Okay, and then we pass that into DB here. So I don't know why, but use in-memory database. What does that do? Configures the context to connect to an in-memory database. The in-memory database is shared everywhere or anywhere the same name is used, but only for a given service provider. To use the same in-memory database across service providers, call in-memory. Okay. await using var ctx so we're creating a bit engine class, okay, and we're passing in options here, passing in those options, and so we get this variable here, and then I say var cache, so I'm creating cache, new campaign cache, that connection object, okay, this appdb context, so that's that class, it's just a class, and then a fake logger, okay. But this campaign cache is a real object, right? New campaign cache, yeah, so this one is going to be a new object, but a real one. And I'm passing these in as the constructor. Okay, here we go. So it's a campaign cache, and now I want to do cache, and then get async. Now, is that, this is cache, which is different than campaign. Because we did this get async, but that's for this DB right here. So we're not doing it for DB, right? So I have an actual campaign cache object. Then I get campaign asynchronously for campaign ID. And now campaign is where this is a real campaign, okay, yeah. And then the result should not be null. So we should get a result, and the result ID should be campaign ID. Where is the mocking though, right? This snippet is setting up an entity framework core in-memory database for testing. Let's break it down. Options equals new DB context option builder. Here, this is what we saw. Creates a builder object that lets you configure how appdb context should connect to the database. How it lets you connect to the database. Okay, so I'm changing the settings of how to connect. Use in-memory database tells entity framework to use in-memory database provider instead of a real SQL database, okay? So we're getting a unique ID for each one, so tests don't share states. If you've used fixed strings DB, all tests would share the same in-memory database instance. Okay. options produces DB context options object with the configuration applied. Isolation in tests. Each test generates a fresh empty database. A fresh empty database, okay. No external dependencies. You don't need a real SQL server or Postgres running. Okay. Speed. In-memory provider is fast and lightweight. I just remembered something. Hold on. Whoops. Oh, come on. What is the command? The git command to go back to the last commit. Because now this is going to say here, and I didn't want to modify this. Come on. Or commit to the remote repository. No, that's not what I want. Discard changes permanently. The commit is removed and all changes associated with it are deleted from your working directory. Use it with extreme caution. No thanks. So I think I'm just gonna go like this and go like this and then go like this. I was just trying to see, hopefully I didn't mess anything up. I think it was kind of like this. And then like this. Yeah, I think it was like this. Okay, and it went away. All right, good. But I just wanted to see if there was an easy way to... Never mind. Okay, fine. Whatever. That's not what we're trying to do right now. We're trying to understand all of this mocking stuff. So I should still have my test though, right? Oh, I have not pulled yet. Git pull. Okay. Now, no wonder. I was like, wait, what? What's happening? Here we go. Okay, that makes sense because I did the merge on GitHub itself in the last video. Okay. So I was on cache, wherever cache's services. This one. Okay, so we have this. I'm trying to figure out, would it be easier for me just to go and try to watch some YouTube videos about this, because I'm not immediately seeing it, and so I don't want to be spinning my wheels and not learning very much. Maybe we can go back to the other document, like this one. Yes, yeah, like this one. But yeah, just going through this, trying to understand what's happening. I don't know if I'm just tired a little bit or what, but it's kind of just like my eyes seem to be glazing over and I'm not able to quite understand what's happening here. Oh, whatever. So, bid selector, budget search, all of these are just talking about the different tests that it wants to run. This one here, this guide explains everything added to test bin and okay. Integration test skeletons, GitHub action workflows. This one was I was trying to figure out what state I was in, but we actually kind of figured that a lot of this out. We tried running this and it worked. Okay, run a single test. We can test a single one. Integration test locally, manual setup. Option A, use Docker Compose. Recommended if project repo includes a compose file, which it does. So we can Docker Compose up specifically Redis and Postgres, and then test known. Okay. Ensure integration tests are not skipped, and then run this command. Okay. The pull request, jobs. Okay, so the next question is how do we move forward with this project? I probably need to go and like actually figure out how these mocks are being used and how you can. I need to get more familiar with that, and I think I'm going to watch some YouTube videos on this one. The second thing that I can do with this project is now that we have things kind of working and we have a general idea about the project itself, this project, not the unit tests yet. I need to continue to learn about those. Or the integration tests. I haven't even really looked at integration tests. That might actually be another thing that we need to try to figure out how integration tests are going to work. But although those seem pretty short. Okay, let's assume that we are able to understand these, the test section. I think next is going to be trying to go into these, add server and analytics service, and think about the project of how, and event consumer as well, how we're going to be able to create these microservices in a way that makes sense for the project. So I think that's the next direction that we're going to go. Yeah. Okay. Or should I go and try to expand on the bid engine itself? Not sure yet. I'm gonna be thinking about it. But anyways, thank you guys for watching. If you want to follow along on this, subscribe. I would love to have you along for the journey. My name is Timothy Lee Grant, and I'll see you guys